All right, welcome back.
Hello.
So we had quite a bit of free response questions last period. So I'm planning on giving you two free response questions after this, which I'll send about 10 minutes after we finish.
Okay.
So which ones I send kind of depend on how we do in the PowerPoint. So we're continuing with last class period with all of our curve catching stuff. So that's analyzing graphs with their first and second derivatives. I'm also looking at separable differential equations today. So to start out, I've got this crazy function here. And I'm just going to jump down the line, I guess. So starting with Oliver, can you give me the x-coordinate of the critical points that are on the interval, and then justify your answer?
Um, that x equals 0 because the slope is 0 and it's changing slope.
Okay, does a critical point have to change slope or not?
No, no.
No, okay, so just derivative is 0 is fine. Okay, and then one more.
At 5, x equals 5.
So at x equals 5, we've got a piecewise function. So it's not that our derivative is undefined, it's that we don't have a derivative at that point. We've got two different derivatives from the left and the right, so that's actually not a critical point.
3.
3, okay. Then over to Junho. So I need each relative extrema, and then whether it's a minimum or a maximum, and why.
The relative maximum at 0 and 5.
Okay, relative maximum only at 0, but
Oh,
why is 0 a relative maximum?
because the the f prime is changing positive to negative.
Slope is changing from positive to negative. In order to be a relative extrema, we also need the slope to be 0 at that point. So slope is 0, and we're changing from positive to negative. Okay. So the reason why 5 is not a relative maximum is because the slope is not 0.
Okay.
Okay, and then I've got one more relative minimum somewhere.
Relative minimum at j. The slope is changing negative to positive, and slope is 0.
Perfect. Slope is changing negative to positive, and slope is 0. Oliver, part C. On which intervals is the function increasing and decreasing?
So for example, from negative 1 to 0, I can say that the slope is increasing, but the curve is decreasing. The rate.
Okay, that's true. If I'm just looking for when is the original function increasing, though, what would the whole interval be where we were increasing in that part?
From negative 2 to negative 1.
I can go beyond that. Was I increasing?
From
Go for it.
from negative 2 to 0.
Negative to 0. Okay, we can do a little bit more than that still. Were we increasing before that?
Oh, yeah, from -4 to 0.
Okay, from -4 to 0, we are increasing. Are there any other intervals on this curve where we are increasing?
Yes, from 3 to 5.
3 to 5, okay. If you had to justify your answer, what could you say?
The slope is positive.
Slope is positive. Okay, so if I was going to write that, you could write maybe f prime x is greater than 0.
Okay.
Okay, cool. Over to Junho. Um, can you tell me the x-coordinate of the points of inflection showing on the graph?
Uh, uh, 1.
1. Okay. So our concavity changed there from negative to positive. Okay. Um, then intervals where we are concave up and concave down.
From -4 to -2, we are concave up. From -1 to 1, we concave down. From 1 to 5, we concave up.
Awesome. Okay, and the last one. I want to find the line tangent to f of x at 6, so what do I have to do?
But I have a question. How do I justify it?
Oh, I'm sorry. How do you justify it?
How do I...
So your second derivative would be positive. That means f prime prime of x is greater than 0 when you're concave up.
Oh, okay. I see.
Okay, Junho, over to you. I need the line tangent to the curve at x equals 6.
Y equal 2.
Okay, y minus b, so
Y minus 0.
not 0.
Wait.
We were given a point here.
Or 3
Okay,
equal 3.
okay, the derivative.
-3.
Derivative at 6. Okay, here's the point at 6. What's the slope at that point?
Well, -3.
Negative 3. Negative 3 times x minus what?
X minus 6.
That's it. And we can leave it like that unless it asks you for slope-intercept form. If they just ask you for the equation of a line, you can give them any equation of the line you want. Okay, so I'm going to jump through these as fast as we can. If f is increasing, what's happening to f prime?
Increasing.
Staying the same.
F prime won't. F prime could stay the same, but it doesn't have to.
So it increases or stays the same.
Not necessarily either. So this graph is increasing and f prime is decreasing. This graph is increasing, f prime is increasing, and this
Oh.
graph is increasing and f prime is staying the same. So what do all three of these graphs have in common?
The slope is positive.
slope is positive, and f prime is the slope, so f prime is positive.
Okay.
Okay, what should the next one be then?
Negative.
Negative.
Negative. Okay.
If f prime prime is positive.
Yep.
So the other one is negative.
That would be concave up, so something like that, or concave down. Okay, what's happening to my first derivative if we were concave up?
Negative to positive.
The answer is not positive or
But
negative,
it
so that
also
would tell
can be
us whether we are
positive.
increasing or decreasing.
No. 0.
If f prime is 0, then we are not increasing and not decreasing. So if the slope is 0, we could be concave up or down. So that's not what we're looking for. If you want to think in terms of physics, then when you are concave up, so that means when you are accelerating, what's happening to your derivative? So what's happening to your velocity?
It's getting faster.
Getting faster. Okay, so f prime is increasing. When the graph is concave up. Okay, the slope of my slope is my second derivative, right? So if the slope of f prime is positive, concave up, then f prime must be increasing. If the slope of f prime is negative, because we are concave down, then f prime must be
Decrease.
decreasing. Okay, cool. Any questions here?
No.
All right. A little short on time, so I'm going to skip a couple slides towards the end, but and briefly overview separable differential equations. We've had this before, so it'll be fast. There are several different scenarios where you might want to define your function in terms of the derivative instead of the function itself. An example we've seen a couple times in class is a logistics equation. So this is an equation for the population of a population of anything really. So population of bacteria, population of people. We usually define it in terms of our slope instead of the population itself. So if I take a closer look here, if I take the limit as p approaches L right now, so as p gets closer and closer to L, this will become 1 minus L over L, which is 1 minus 1, and the slope will become 0. So if the population gets close to your limit, then the slope of the population becomes 0. If my population approaches 0, then my change in population over time also approaches 0. So as our population gets down to 0, the slope of this equation also gets down to 0. So we end up with something like this. A function where the concavity changed right in the middle at L over 2. That was defined in terms of our slopes. So our slope becomes 0, close to a population of 0, or close to a population of L. Okay, so L is our carrying capacity. That's how much your environment can support. So if you release a bunch of bunnies onto a really small island, maybe that island has enough vegetation to support 1,000 bunnies. And if they get over that number, then some of the bunnies won't be eating enough to keep surviving. So your population will increase exponentially until resources get more and more scarce. And then it'll increase logistically until it reaches the maximum population that it can support. Any questions on what's happening here?
No.
No.
Okay. So one more on this. If I take a look at my second derivative, so I'm going to use this one. And if I take a look at my second derivative, we'll take product rule. So because k is a constant, this will become k times L minus b plus kp minus 1. So this will be kp times negative 1, which is k negative p. Okay, I can factor out my k, and I'll get k times L minus 2p. If I wanted to set this second derivative equal to 0, to figure out when the concavity will change. So when does our population stop accelerating its growth and start decelerating its growth? So if I do, I can say 0 equals k times L minus 2p was our second derivative. K is a constant, so I can divide that by both sides and it will cancel. Move my 2p to the other side and divide by 2. So whenever your population is at L over 2, our concavity is 0. You can kind of see it on the graph, I think. Here at L over 2, our growth rate is the fastest. Okay. So let me break out of this and we'll take a look at one problem.
Okay.
Okay, so this is actually one from your homework. So I'm hoping you guys have done this one already. I'm going to skip sketching the slope field for now and look for our particular solution, since that's what we talked about today. So I'm actually doing part B. I'm going to do it in part A's slot, just because that'll allow us to see the equations. So I have dy over dx is equal to negative 2x over y. And we were told that f of 1 is negative 1. Okay, if I wanted to write an equation for the tangent line, what would I have to do?
Y
Y plus 1.
plus 1 equals negative 2x over y.
Okay, what is x, what is y?
X is 1 and y is negative 1.
Okay,
So it's just 2.
right. And then what goes here?
X minus
X minus 1.
Okay, so there's our equation of the tangent line. And I'm going to use it to estimate what will the y value at 1.1 be. So I'm going to plug in 1.1 for my x value, and we'll see what our y value ends up being. So this is y plus. Let me box this in really quick, because that was the first part they asked us for. I'm actually going to make a new line, because they had two parts to this equation. So y plus 1 equals 2 times our x value, 1.1, minus 1. So I've got 0.2 minus 1. What is 0.2 minus 1? Okay, negative 0.8 is our...
Why is there 2 times 1.1 minus 1?
So 2 is our slope.
Oh, there's a... okay, I see.
And I just plugged in 1.1 into our tangent line equation.
Okay.
Okay. And the last part, I want to find the particular solution to the given differential equation with the initial condition f of 1 equals negative 1. So I've got dy over dx equals negative 2x over y, where f of 1 is negative 1. Okay, how do I solve this separable differential equation? What's my first step?
What's a differential equation again?
So a differential equation is an equation for the slope. So this is dy over dx. Change in y over change in x is my slope. My slope is negative 2x over y. If I want to solve this equation, so my goal is to get y alone, what would I have to do? I think I've said before, this is the single point on the free response question that's worth the most out of all, everything you'll do on the AP exam. So your first step here, because if you don't do your first step for these differential equations, then you lose out on 5 or 6 points. So it disqualifies you from points in the future, which is unusual. What's the first thing I have to do?
Separate the variable.
Separate the variables. Okay. So separate variables. So that means move all the y's to one side, y dy. Move all the x's to the other side, negative 2x dx. Okay, I'm going to try to make each line another color. Okay, then what? Okay, right now I've still got a dy, so I need to get rid of my dy's and dx's. So, what could I do? Integrate, perfect. Okay, let's do this. So this will be the integral of y dy equals the integral of negative 2x dx. What happens when I integrate y in terms of y?
Y squared over 2.
Squared.
Y squared over 2 equals what?
Y. Minus 2 x squared over 2.
Okay, I'm going to throw my plus c on this side. The reason why I've only got a plus c on this side is because if I put a plus c over here, plus c, I could subtract that c, and I would still end up with a constant because they're not the same constant. So c minus c is still c. So you only need to write one of these plus c's. Okay. Then I might stop at this step because this is a good time to plug in my x and y and solve for c. So I'm going to do that next. So I was told y is negative 1 when x is 1. So if I plug that in, what happens?
One over 2 equals negative 1.
Okay, therefore c is equal to 3 over 2. Okay, so that means we can come back and keep going. Okay, so now we've got y squared over 2 is equal to negative x squared plus 3 over 2. Okay, so we just plugged in c. Okay, and my goal is to solve for y, so we just need to solve for y from this point. So how can I solve for y?
Mm. Y times 2.
Okay, multiply by 2, so y squared equals negative 2x squared plus 3. Okay, last step. Y is equal to what?
Root. Root of negative 2 x squared plus 3.
Okay. Okay. So we've got our general form for the equation. In order for this equation to work, my x cannot be big enough to make this equation negative under the root, right? So we've got a set range where this can work. If negative 2x squared plus 3 ends up being less than 0, then we're in trouble, and this function won't work. So I've actually got a limit on my domain, so the limit on which x value we can plug in. So I'm going to move this over. This will be negative 3 divide by negative 2 on both sides, which will change my sign. So x must be where did I go wrong? I started with the wrong sign. Oops. Alright, I'm going to keep it the way I had it. So if x is this, if x is greater than the square root of 3 over 2, then y is imaginary. Therefore, my domain, so x, must be between negative root 3 over 2 and positive root 3 over 2 for this function to exist. Okay, any questions on what we did?
Yeah, what was the last part? Like, how did we do that?
So this last part is my domain. If you notice, if I plug in a big number for x right now, so let's say if I plug in 4, That'll give me negative 2 times 16 is negative 32 plus 3 is negative 29 underneath the root. I can't have a negative number underneath the square root, right? So this is checking for the domain.
But what's the domain?
Domain is which x values are okay. For what x values would this function actually exist? What x values can I plug into this function? Okay, so I kind of checked for the opposite. I said if we are less than 0 underneath the square root, then our function cannot exist. So if x is greater than root 3 over 2, we will not exist.